Okay, so after watching Annenberg Lerner's video on measuring the area of triangles, I've decided to try Geoboard, which I've heard a lot about and I've never tried before. So I've opened up Geoboard and GeoGebra, and I searched for area with a Geoboard, and this workbook came up. So I'm going to try the first one here. And in Annenberg, what they were doing with the Geoboards was taking irregular shapes and using the rubber bands to dissect the shape and figure out the area with the shapes. So here we go. The first one I'm going to do is this square I see here, and I see that's 1, 2, 3, 9 units, and then I'm going to do this one. It's 2 more units. I'm going to add this one, so that's 3 more units. And then I'm going to take this square here, so that's a half, and another half. And then I've got 2 more halves here. And I can do the same here. So I thought I saw a writing tool. This we said was 9. Nope, that doesn't work. Okay, so that's 9, 10, 11, 12, 13, 14, 15 units. And that's 15 units there. So I'm going to go back, and they have in this set different ones. So I tried that one. The next thing that they did in the video was ones that didn't break up into exactly half. So this one looks like that might be a good example. So when I look here, I have these 2, and then this one here, if I'm looking at it, isn't exactly half. So I'm going to make a larger rectangle around it using the base of this here. And so looking at this rectangle, this section here would be half of it. And then I can do the same up here. And so this would be half of 1, 2, 3, so that's 1 1/2, 3 1/2, 4 1/2. Is that right? 1, 2. Then half of 3 is 1 1/2. And then half of 2 is 1, so that's 3, 4 1/2. And there's no checking this one. Okay, there's no checking that one. Okay. Oh, look, there's a little window there. Okay. So let's try this one. I don't know if that's going to help. I'm looking at this one. Oh, I don't think that's what I wanted to do. Undo. There we go. Undo. Okay. So I can take away half. That still doesn't give me. What if I did? Nope. What if I went bigger? Okay, and then I'm thinking it has something to do with this one because it's on a dot. If I could figure out how to subtract this space, because I know that this whole space is going to be half of this green rectangle. So I know that this triangle is 1, 2, 3, 2, 3, 4. This whole triangle here is 6. And then nothing else lines up. So if I were to make this could I make this a triangle? And a rectangle? No. Okay, let's see. I can take away this square and I can take away, can't take that away. Oh, I can. I can take away this. I can take away this. And then I can take away this. Okay, let's see. If I have 1, 2, 3, so if my large rectangle is 12, then this half is going to be 6. And now I'm going to start to subtract. I can subtract this square, so that's 1. And then I'm looking at this area here, this triangle, and if I make that into a rectangle, that's 2, and I'm going to take away half of that, so that would be 1, another 1. And then down here, if I want to take away this triangle, I'm going to make a rectangle out of it, and that's 3, so that's taking away another 1.5, 6, 5, 4, 3, 2.5. So that's 1, 2, 3, 4, 5, 6. Okay, so 2.5. Let's try it. I got it, yay. Okay, let's try one more. I can go, oh, you know what? I hit the wrong thing. Go back to this book. And I think that was probably, let's try this one. Okay, so same thing. If I can look at this and say 1, 2, 3, 4, then this here is going to be 2, but then I need to take away this white space, and that is half of this square, so it's 2 minus a half, 1.5 for this portion. And then I've got this little parallelogram right here, and I can do two, and then 2 halves is 3, and then the same thing down here. There's probably a way shorter way to do this. So this is 1, 2, 3, 4. So this is going to be 2 minus a half is another 1.5. And that's going to give me 3, 4, 5, 6. Okay. Okay, another one I wanted to explore was in the second half of Annenberg, they were talking about developing formulas for parallelograms and area of parallelograms and the area of triangles. And so when I searched GeoGebra for parallelograms, this one popped up, and I thought it was a nice feature for playing with Geoboards. And so you have these 3 figures that you can work with and manipulate. One with 3 sides, and then 4, and then 5. So for parallelogram, I'm going to use the green one, and I've created a parallelogram here. And so the formula that we're working with is base times height. So if I'm looking at this and I create a parallelogram with a base of 4 and a height of 1, then I should be able to say that the area of this parallelogram is going to be 4. And then I can manipulate it in I can do different parallelograms to test out to see if it works for different ones. So this one, I'm looking at a base of, again, 2, 3, 4, and a height of 1, 2, 3, so the area should be 12, and it does. So that was parallelograms, and we can do all sorts of different sizes and shapes. And the next one was triangles, with the formula being half the base times the height. So I can manipulate different triangles. So here I have a base of 1, 2, 3, 4, 5, and a height of 3. And 5 times 3 is 15, and then half of that is 7.5, so area is 7.5. And I think, let's try one more. So here we have a base of 2 and a height of 1, 2, 3, 4, 5, 6, 7, 14. Half of that is 7. Okay, this is the last little bit that I have been playing around with, and I know it wasn't in Annenberg, but I came across the area of a circle, and I thought this was a really interesting demonstration where you have here the circle, and you can play around with how many pieces it's divided into, and then these two markers here on the side is, after you divide it up into pieces, it shows you spreading them apart and then lining them up so that you can figure out the area of a circle, where the formula comes from, using radius and pi. I thought that was an interesting demonstration. Okay, I know I said that was the last one, but really, just playing around with this GeoGebra, there's so many great visuals for area of different shapes. So this is just another demonstration. Is the area of a pentagon, and again, I know this is more than what was on the video, but not too far from where we want to go, and showing how you can break it up and open it up, and then the question at the end is, can you write a formula for the area of a regular pentagon? And I'm curious to see if there are other demonstrations that'll help maybe let kids investigate this a little bit more. We'll just look real quick, area of a regular pentagon. So here I was just searching for, in the last part of the video, they were doing doubling of area, and I haven't found anything that I would say is useful. Area of a not as useful as the tiles, but I feel like it's kind of sent me down a rabbit hole with all of the other things that you can discover on GeoGebra. So I have a feeling that I will be spending a lot more time on here. This seems like a very handy tool to use. Area of different polygons. And most of this looks, I wonder if there's a better way to sort through it, or if it's just spending countless hours finding what you need. this one look like maybe oh, this is for so the only one that I found for kind of experimenting with area and scale factor was this one. I was hoping to find one that you could manipulate a little bit more, but I think that this one gives a good visual for what happens when you are increasing the area of a square. So if we start out at 1 square unit and we want to double it, then it shows how we're growing length and width. And so we're not just increasing 2 units. We're going to 4, and then if you want to triple it, and then you can play around with it a little bit, but that's kind of a limited feature but useful. And that's it.